Hi everyone, my name is Andrew Koch, and today I'm going to talk about the paper Tectonic Shift, a composite storage fabric for large-scale machine learning training. This research comes from Meta and focuses on improving how massive machine learning training jobs access and store data efficiently. To start with some background, large-scale machine learning models, especially recommendation system or foundation models, rely on huge data sets that are read over and over again during training. Meta's previous storage system, called Tectonic, mainly used HDDs to store this data. HDDs are great for capacity and cost, but not great when it comes to input output per watt, meaning they require a lot of energy to keep up with the fast read requests. As Meta's training demands increased, the system simply did not scale well. It will require too much power and hardware to keep up. Of this, the authors introduced Tectonic Shift, which is basically a hybrid storage architecture. Instead of replacing everything with Flash, which would be extremely expensive, they had a Flash-based tier called Shift in front of the HDDs. Flash is much faster for repeated reads, so this new layer absorbs most of the heavy read traffic, reducing how often the HDDs are touched. But what really makes the system interesting is that it doesn't use a basic caching policy. It relies on application-aware caching, meaning it predicts future data usage by looking at a dataset structure rather than guessing based on recent activity. So it's not just faster storage, it's smarter storage. The results show meaningful improvements. Shift absorbs about 1.5 to 3.3 times more input output than a standard LRU cache. And when rolled out to a real production system at Meta, it reduced storage related power consumption by around 29%. Considering this is happening at a petabyte scale, those savings translate into major long term efficiency gains. Looking at strengths, I like that this work is practical and deployed, not just simulated. It solves a real world industry problem and does so in a cost conscious way, showing that hybrid system designs can be both scalable and energy efficient. I also think that the application aware caching approach is a clever idea because it takes advantage of the fact that machine learning training workloads are often predictable instead of random. In terms of limitations, the performance results are based on Meta's internal workloads, which are extremely large and structured, so the improvement might not be as significant for smaller companies or more irregular data pipelines. Also, the caching technique depends on having accurate metadata about datasets, which might not always be available or easy to integrate. And finally, while power improvements are highlighted, the paper doesn't go very deep into long term cost, maintenance, or hardware lifecycle trade offs. Tectonic Shift is a strong example of how scaling machine learning infrastructure requires thoughtful design, not just newer hardware. By combining HDDs and Flash with smarter caching, the system manages to achieve higher performance while using less power. Overall, I think this paper is a useful and realistic contribution for anyone interested in high scale systems, data engineering, or machine learning infrastructure. Thank you for listening.